Hi everyone. My name is Karthika, working as an assistant professor in Department of Computer Science and Engineering in St. Martin Engineering College. So here I am going to discuss about deadlocks in operating system. So first of all, what is deadlock? So deadlock is actually it is a situation in which some processes are blocked and it is holding some resources and waiting to get another process to be continued. That is a situation of deadlock. That means if there is more than one processes, all the processes are get blocked. No processes is possible to continue their execution. That is a situation of deadlock. So whenever I am discussing about a real world situation in deadlock, you can say that there are two trains coming together in different tracks and they come across a crossing game. So what happened is one train has to wait there and wait for another train to continue. That is a situation of deadlock. So what happened is both trains has to wait to continue with another train. That is one example of deadlock in real world situation. Okay, so whenever I am going to another example in real world situation, I can say that there are two persons. We can say it as Zain and Fatih. So they are working in a office and they are working together in the same database. That means both are working for a same database and accessing the data from database and make some edits in same database. So database always contains different number of tables will be there. So we can say that there will be two tables, table A and table B. So Zain is working on table A. So what happened is at the time of working in table A, that table is get locked. So no other persons can edit table A. Just like Fatih is also working in table B. So what happened is table B is also get blocked. So no other persons can edit table B. But what happened is both persons want to edit or they want to continue their editing. But what happened is the other tablers now get blocked. So no persons can continue their editing. So that is one another situation in deadlock. So I can say one another example in real world, that is two persons went to a restaurant. So what happened is they are ordered a food and the restaurant person is provided one fork and one spoon, but one person has accessed one fork and another person has accessed the spoon. So what happened is if they want to continue the eating, they need both fork as well as spoon. So what happened is there is only one fork and there is only one spoon. So both cannot continue their eating while they have to wait for others. So but the situation is just like nobody is yet started their eating. So this is a situation, another situation we can say that deadlock in real time situations. So I am going back to my situation in processors. So in processors, we can say that there will be two processes and they are working on different files, or they are using different resources. So what happened is one process is already holded one resource and it is waiting for or requesting for another process or another resource to continue. But the problem is another process is already holding one resource and they are waiting or requesting for another resource to continue their action. So that is a situation in deadlocks. So I will explain one situation, that is there will be one process and there is one resource. We can call it as P1 and we can call it as R1. So P1 is already holded R1 and there is another process P2 and there is another resource R2. So P2 is already holding R2. So here the situation is just like both processors are holding one resource each. And next one is P2 needed R2, so it is requesting for R1. Just like that, P1 is requesting R2 and it is requesting for R2. So what happened is if P1 want to continue their execution, it needs R2. Just like that, if P2 want to continue its execution, it needs R1. So this is a situation of deadlock in processes. So how we are going to define deadlock in processing or computers? We can use a resource allocation graph. So that is called as resource allocation graph. So what is resource allocation graph is? How they can represent resource allocation graph is, I can say that it will be just like a graph only, but there are some definitions for resource allocation graph. One is the process always should be represented in circle. So P1 or P2 or P3, how many processes are there in resource allocation graph can be represented in a circle. And another thing is, the resource can also be represented as a square or rectangle. We can use a square or rectangle to represent a resource. So this is the definition of resource allocation graph. And another thing is, there will be some arrows in resource allocation graph. So one thing is, it is from process to the resource. So that type of arrow is representing that process is requesting for the resource where the arrow is going. That is the representation of if the arrow is coming from process to the resource. Just like that, if there is another resource and the arrow is coming from resource to the process, the meaning is that particular resource is already allocated to the process P. So this is the meaning of resource allocation graph. So in resource allocation graph, process will be represented as circle, resource will be represented as rectangle or square, and there will be two type of arrows. One is from resource to the process, that is meaning is that particular resource is already allocated to the process. If the arrow is just like from process to the resource, means the process is requesting for the particular resource or waiting to get the allocation of that particular resource. So this is the meaning of resource allocation graph. So next is, will represent one situation in a processor, situation in a processor, how the deadlock can be represented. So I will use, there is two processes, P1 and there is another process, P2. Okay, so next thing is, there will be two different type of resources. So I can say that R1 and R2. There is R1 as well as R2. So this is a particular thing in a situation in a processor. So what happened is, R1 is already allocated to P1. So the arrow will be from R1 to P1. That means R1 is already allocated to P1. Just like that, R2 is already allocated to P2. So the meaning will be, so the arrow will be R2 to P2. The meaning is P1 is already allocated to R1 and R2 is already allocated to P2. So this is the meaning. Next is P1, if P1 want to continue the execution, it needs the help of R2. So the arrow will be from P1 to R2. Just like that, P2 want to continue their execution means it's need the help of R1. So P2 will be requesting for R1. So this is the situation of, in a processor, there are two processors and there are two resources. We can say that some example for R1 and R2 is, R1 may be a printer and R2 is one file in the folder. So P1 is using the printer and it is already allocated to P1, but it needs some editing in the file which want to be printed. So that is actually R2. Just like that, P2 is already using or some editing in the R2 and it needs to print the file. So what happened is, P2 already using R2, but it needs printer also. So this is a situation of deadlock. So what happened is, both processes P1 as well as P2 cannot continue their execution. So both processors get blocked in the processing system. So this is an example for deadlock in a processor. So next is, there is one situation called as multiple entities or multiple instances for a particular resource. That means just assume that there is two processes. So there is two resources which is having R1 and R2, but here you can say that in R2 you can say two dots. The meaning is R2 is having multiple instances. That means just assume that R2 is file, means there is multiple instances of same file is there. So what happened is one instance can be allocated to one process, just like that another resource, another instance can be allocated to another resource. So actually, if resources is having multiple instances, it is actually reducing the possibility of deadlock. That is actually happening in a resource allocation graph. This is a representation of resource allocation graph if it is having multiple instances. For example, here P1 and P2 is there. The meaning is R1 is actually arrow from R1 to P1. So the meaning is R1 is already allocated to P1. And the arrow from P1 to R2, the meaning is P1 is requesting for R2. Just like that, the arrow from P2 to R1, so the arrow will be from P2 to R1 means P2 is requesting for the resource R1, and the arrow from R2 to P2 is representing that resource P2 is requesting for the resource R2. So this is the meaning of resource allocation graph. And one more thing you can see here, there is another process P3. So the another instance of R2 is already allocated to P3. So after seeing this, you may be think that there will be a situation of deadlock. Is it? Because R2, both instances are already allocated to two different processes. Still, P1 is requesting for R2. So there may be possibility of deadlock. No, what happened is, it is actually reducing the possibility of deadlock. How means, there is two resources or two instances possible. One instance is allotted to P3, but what happened is P3 is actually not waiting for any other resource. So here the situation will be like P3 will continue its execution and it will complete the execution, and then that resource will be deallocated. So now what happened is that another instance of R2 is free now. So you can allot that particular free instance to the particular P1. So P1 can continue the execution and complete the execution. Now P1 will release R1 and R1 can be allocated to P2 and P2 can continue the execution. So what happened is, there is no blocking of processes. There is a possibility of continuing the execution of each process, and they can continue their execution and complete their execution without deadlock. So this is the situation of multiple instances in resource allocation graph. Now we will see another example. You can see two different resource allocation graphs, which is one graph is having deadlock, another resource allocation graph is not having deadlock. We can see that here what happened is P1 and P2, there are two processes and there are two resources R1 and R2. But here what happened is both resources R1 and R2 is having only one instance is possible. So the situation is, as we discussed before, P1 is R1 is already allocated to P2 and it is requesting for R2. Just like that, R2 is already allocated to P1 and P1 is requesting for R1. So what happened is, it is a situation of deadlock. That means both processes cannot continue their execution, they got blocked. But here what happened is, just as we discussed before, it is having multiple instances possible. So there are three processes, P1, P2 and P3. Four processes are actually P1, P2, P3 and P4, and only two resources are possible. But here the situation is just like R1 is having two instances as well as R2 is having two instances. That is the situation of multiple instances. So as we discussed before, P1 is requesting for R1, but two instances are already allocated to P2 as well as P3. Just like that, P3 is requesting for R2 and 2 instances of R2 is already allocated to P1 as well as P4. So you maybe think that there is a situation of deadlock, but as we discussed earlier, there is the possibility of continuing the resources. How means P2 can continue their execution, and after completion of the execution of P2, the another instance of R1 can be allocated to P1. Just like that, here also P4 can continue their execution, and after completion of their execution, the another instance of R2 can be released and it can be allocated to P3. So what happened is there is a possibility of continuing all the 4 processes and there is no deadlock situation arising. So this is about resource allocation graph. So how we are identifying deadlock situation in a resource allocation graph is, if there is a cycle formed inside a resource allocation graph, then there is a possibility of deadlock. But still we have to continue this situation also. If there is a possibility of continuing any other instances, then there is maybe there is no possibility of deadlock. It is also possible. So what happened is, if there is only one instance, you can surely say that there is a cycle in resource allocation graph is leading to a situation of deadlock. But we cannot say that in multiple instances. We have to analyze that resource allocation graph, then only we can say that there is any deadlock or not. But in the case of single instances, it is sure that if there is a cycle in resource allocation graph, it is a possibility of deadlock. So this is about resource allocation graph. Next is conditions for deadlock. That means what are the conditions it should be there in a processor if deadlock situation can arise. So that is about conditions for deadlock. So first condition is, these are the 4 conditions that can lead to deadlock situation. One is mutual exclusion, second one is hold and wait, third one is no preemption, and fourth one is circular wait. These are the 4 necessary conditions that leading to a deadlock situation. So you should say that it will be a necessary condition, because if the system is having all the 4 conditions, then only there is a possibility of deadlock. So you can call it as necessary conditions that is leading to deadlock in operating system. So we will discuss each conditions one by one. Okay, so these are the necessary conditions of deadlock situation. So we will discuss each condition one by one. So first condition is mutual exclusion. So mutual exclusion means each resource, either it should be available to be allocated or it should be allotted to at least exactly to one process. That is a condition of mutual exclusion. That means if there is one process called as, you can call it as R1. So this R1 either should be free. So that means if there is one process, P1 and another process P2, and there is one resource R1. So either R1 should be free to be allocated to either P1 or P2. That is one situation. Otherwise, R1 has to be allocated to exactly to P1 or exactly to P2. But it is not allowed to allot R1 to both P1 as well as to P2. So that is a situation of mutual exclusion. That means one resource should be either free or it should be allocated to exactly one process. That is a condition of mutual exclusion. It is not possible to allocate. This is actually not a possible situation. That means R1 is allocated to both P1 as well as to P2. This is not possible. This is a wrongly mutual exclusion. So it is not a possible situation. So this is about mutual exclusion. Another situation is called as hold and wait. So what is hold and wait is, hold and wait means one process is holding one resource and it is waiting for another resource. We are already discussed what is situation of deadlock. So if the system is allowing hold and wait, that means the process can be hold one resource and it is waiting for another resource. That is a situation of hold and wait. So you can see in this example, that is, there are two tasks, task 1 as well as task 2, both are can be set as two processes, and task 1 or P1 is already allocated printer or it is using printer. So printer is already used by task 1 and now task 1 wants scanner. So that means task 1 is requesting for scanner. Just like that, scanner is already used by task 2 or P2 and P2 or task 2 is requesting for printer. So this is a situation of hold and wait. That means one process is holding one resource and it is requesting for another resource. That is the situation of hold and wait. Next one is no preemption. So no preemption means if one resource is already allocated to one process and it cannot be forcefully taken from the process. That means once it is allocated to one process, if the resource is free means that process has to be completed and it is deallocated that particular process. So it cannot be forcefully taken back from the process. It should be voluntarily release that particular resource. That is called as no preemption. So preemption means we can take the resource forcefully from a resource, from a process, and it can be allocated to another process. If, for example, if there is higher priority processes arising, sometimes the operating system will do that. That means that already allocated resource will be taken from that particular resource and it will be allocated to the higher priority process. But if there is a situation of deadlock or there is a possibility of deadlock means it should not be there. That means no preemption will be there. That means already allocated resource cannot be forcefully taken and can be allocated to another resource. It is another process. That is not possible. That is a situation of no preemption. Finally, the fourth condition is called as circular wait. Circular wait means there is some processes are already there in the system and they are actually waiting circularly to each other. For example, in this example, there are three processes P1, P2 and also P3. P1 is waiting for P2, P2 is waiting for P3, P3 is waiting for P1. So this is actually a circular wait. So if there is a circular wait, then only it is leading to deadlock situation. So these are the four necessary conditions of a deadlock. So one is mutual exclusion, then hold and wait, then no preemption, and finally circular wait. So the condition is just like if the situation is, if the system is having all the four conditions, then only it will lead to deadlock. That means just assume that the system is not allowing hold and wait situation. That means the process cannot at a time cannot be holding one resource and waiting for another resource. That hold and wait situation is actually a particular system is not allowing. So that means there is no possibility of deadlocks. The meaning is at least one condition is not there means the system will not go for a deadlock situation. So these are the necessary conditions. All the four conditions should be there to become a deadlock situation. So this is about the necessary conditions of deadlock. So next one is how you can prevent the condition of deadlock. There is actually mainly four conditions or four situations will be there. How you can prevent deadlock situation. One is, or you cannot say that prevent, it can be handling a deadlock. One is deadlock prevention. Second one is deadlock avoidance. Third one is deadlock detection. Finally, it is deadlock recovery. So, all the four is some situations for some handling mechanism. Instead of this four mechanism, there is one more thing is that is deadlock ignorance. So what is deadlock ignorance is actually that method is used by usual operating systems. For example, Windows is using deadlock ignorance. So what is deadlock ignorance is sometimes the deadlock situation may not lead for a complex situation. So in that cases, you can ignore that particular deadlock and continue the situation. But what happened is, so sometimes the Windows will restart the system once it happened a deadlock. So it is not handling the deadlock, it is just ignored and continue with another allocation strategy. So that is actually called as deadlock ignorance. So rather than deadlock ignorance, these are the four mechanisms for handling deadlocks. So first one is deadlock prevention. Deadlock prevention means we are already discussed what are the necessary conditions of deadlock. So you have to eliminate at least one of the condition. That is actually the possibility of deadlock prevention. That means these are the four necessary conditions of deadlock. So we have to avoid or we have to eliminate at least one of this condition. Then it will not, may not be leading to deadlock situation. So this is about deadlock prevention. Next one is deadlock avoidance. So deadlock avoidance means it is actually just like if a resource is having, if a process is requesting for one resource, the system will check for a safe state. That means if I am granting this particular resource, whether it will lead to deadlock or not. If that is safe, that means it is not leading to deadlock, then only the process or operating system will grant that request. That is actually deadlock avoidance, one strategy in deadlock avoidance. Another strategy is just like at the starting of execution of each process, what the process will do is the process will acquire all the resources it need for the execution. So what happened is in between there is no request is needed. Already all the resources are acquired by the process. So that is actually two strategies that you can use for deadlock avoidance. So here one algorithm that you can use in deadlock avoidance is Banker's algorithm. So in Banker's algorithm, the system will check for a safe state. If it is safe only, they will grant the request. If the process is requesting for one resource, it will check for whether it is safe or not. It is safe means it will grant the permission resource, otherwise it will ignore it. So that is about deadlock avoidance. Next one is deadlock detection and recovery. Actually, deadlock detection and recovery is a single procedure. That means actually we are not preventing or avoiding the situation of deadlock. We are just allowing the system to become in deadlock. Then at each step we will check for deadlock is there or not. So that is deadlock detection. We are detecting whether it is having deadlock or not. If there is deadlock, we will go for recovery strategies. Otherwise, it will just continue as it is. So actually deadlock detection and recovery is a single procedure. So deadlock detection means we are just allowing the system to become in deadlock. Then at each state, at each moment, whenever we are granting a permission of resource, we are not checking for a safe state. We'll just grant it and then we will check whether it is leading to deadlock or not. If it is leading to deadlock means we have to go for some recovery mechanisms. Otherwise, we can go with the granted permission. So that is about deadlock detection and recovery. So for recovery, there are some deadlock cycles. Actually, already we have discussed what is resource allocation graph. So as it is, we'll detect the deadlock is arised. So we will go for some deadlock recovery strategies. There are some algorithm that you can use for deadlock recovery. Is just we can use for priority of the process. Choose one of the method for deadlock recovery is we are just aborting one process. So how we are choosing a process to be aborted is some point we have to go for. What is the priority of the process, how long the process is computed. If it is at the end of the process execution, we cannot abort it. And resource the process has used, resource process needs to be completed, how many process will need to be terminated, is process interactive or batch. So these type of techniques we have to check, and we will decide whether it can be aborted or not. So that is a method of deadlock recovery. So totally, deadlock means it is all the processes get blocked, and we are looking forward for a handling mechanisms of deadlock. So this is about today's session. Deadlock is a situation, we have to handle it in some way. We have to use some method to handle it. So this is about deadlock. Thank you.